I'm here chest deep in an Emsworth mill pond. These miniature yachts magnify the challenges the America's Cups teams face with their test platforms. Understanding the difficulties of scaling in these boats gives us insight to the priorities and compromises that the America's Cup teams are making on their $1 million platforms. The America's Cup team's scale platforms have some really strange features, and it's not just me who's noticed. Now, seeing as one of the biggest strategic decisions the teams have to make is whether they use a full-size legacy AC-75 for testing, but are limited to old equipment, or using a miniaturized LEQ-12 but are able to test new parts, then it's really fascinating to know what the compromises are that the teams are having to deal with and what workarounds they're using to get the maximum from their smaller test platforms. What are the strange details I and others have talked about? Ineos is dragging around a windward foil, Luna Rossa does the same to a lesser extent, and compared to the AC-75 is missing several feet of bow and struggled for months to self-launch. The Emirates Team New Zealand designed AC-40 on initial viewing looks much better, but it does so with a fat hull and is just actually lifting its foil higher out the water. Ultimately, all these boats serve a similar purpose: to provide a test platform which will feed the teams with information they need to build a cup-winning AC-75. So why do they all appear so different? Let's go back initially to the RC model yachts, because they are an extreme example of some of the scaling issues the teams face. Before I ever sailed, I was fascinated by model yachts at the Marine Lake. And one thing that always caught my eye was how they moved in a kind of twitchy double speed. This is the first problem scaling. True scale speed is equal to the square root of the scale of the model, multiplied by its full size speed. For example, with a 7-knot IACC class at 1/25th scale, the calculation would be 0.2 times 7, which equals 1.4 knots. Scale time is derived from speed being distance divided by time, so things appear to happen faster when scaled down. A boat will roll much more quickly, for example, and this effect is used in films to make scale model ships look more realistic. The scaling down is on a similar basis to speed, so for our full-size IACC, 1 minute in scale time for these IOM boats would be the square root of the scale, which is 0.2 times 60 seconds, which equals 12 seconds. So I have to stretch 12 seconds of footage of the model yachts over a minute to get them looking like they would at full size. So these test platforms, before they get foiling, will always seem to move in a twitchy way. Of course, we can't scale wind speed or wave heights on the open sea. Scale weight, you would need to divide by, well, for the IACC, 25 tons, so 25,000 kilograms, divided by 25, divided by 25, divided by 25, which for these 1 meter models should put them at 1.4 kilo. Now, they're 4 kilos with an insanely long keel, which makes them comparative weapons. Could they make a 1.4 IOM class boat? Well, debatable, because 2.2 kilo is in the bulb. This brings us to the first problem the teams face. If you start from the idea of scaling everything by length, then displacements needs to drop following the cube squared law. A boat that is half length, if scaled in all the other directions, has a volume of 1/8 the original. So to float on the same waterline, the half scale model would need to weigh 1/8 of the full scale. Sailwheel remarked how light the AC-44 was for its length, and the McConaughey's brochure gives an all-up weight of 2,000 kilograms for the AC-40, which is much less than half the weight of the full-size yacht, which is 6,200 kgs. But if the AC-40 was truly a half scale, or actually 57% when you work out the proper waterline lengths, then it should weigh only 1,200 kilograms. So it's actually 800 kilograms overweight. And why can't they make a boat down to weight? Well, there are parts that just won't scale. All the human interfaces on board, all the weight-bearing deck, panel thicknesses that just have to withstand worldly shit happening, like people dropping stuff. None of that can be scaled. But maybe they could get it. Debate that in the comments. I'm not completely sure. But would they want to get it down to weight? Perhaps if hitting the correct weight for a 1/2 scale is difficult, then instead you start looking to see what weight you could make it to, and then think about scaling the beam to that weight. And if you do that, maybe you think, let's make the rig as big as you can on the boat, and then make a boat which is the right weight and right beam for that rig. So it's all kind of like perfectly scaled in terms of the sail carrying power. This seems to be where Luna Rossa and Ineos have ended up. Well, at least seems to be where Luna Rossa have ended up. They very much look like a beam cross section, a perfect scale, and looking aft to stern, they look a perfect scale again, minus a bow. So they're a great replica of an AC-75 when flying, albeit a bit short. And that shortness for Luna Rossa comes at a price. They're still missing some volume. This leaves them sitting low on the waterline and explains possibly some of the reasons why their foil touches and they struggle to get unstuck and flying. But there are still other reasons too why their foil's hitting the water. Even a perfect scale of the new AC-75 class would have it windward foil closer to the water than the legacy boat, and that's simply because the geometry has changed in the new rules. The foils are wider, have a greater span, and the arms are longer, so naturally they will clip the water more often. And we'll see that when the AC-75 start sailing with the new generation foils. Add on to this that the waves these boats are sailing in will be proportionally bigger, and I think we now have a pretty good understanding of why Luna Rossa's LEQ-12 behaves like it does, so that kind of settles that. Let's talk about the AC-40 next, because it doesn't seem to have a lot of these scaling issues. And we've already busted the myth that it's super light. It's actually heavy, 800 kilograms heavy. So why doesn't its foils hit the water? Well, first it just lifts its foils higher than a full-size 75 would. So yeah, I guess that makes it easier to keep them out of water if you just lift them higher. Secondly, its foils do look kind of a little bit small for its beam. So perhaps they bulked out the hull to get it sitting a bit higher in the water, and then reduced the foil arms to keep the leverage the same, and therefore it has a rig which is slightly small for the hull. These are all theories, and it's very hard to get precise measurements, but they're all things that you would probably do if your priority was more about getting a functional 40-foot foiler that can host Grand Prix racing. What do you think? They've clearly made multiple concessions in their scaling, but perhaps the perfect scaling isn't so important, and actually having something that just works as a boat is better for training crew and ultimately even collecting data, because if the boat's really hard to sail, then it's hard to get lots of sailing time and hard to get lots of data. What's with Ineos? Is it just dipping foils like Luna Rossa because it's scale in beam and missing some volume in the bow? Well, no, its windward foil is in the water in the extreme, and something here much more profound is going on. this overlay shows that the foil arms for Ineos are just plainly different. They have a shorter hip on them and a longer leg. Can arms have longer legs? Maybe I should be calling it the elbow. I don't know. Anyway, the plus side is that when the foil's down, the boat has a bit more height because the leg bit of it is longer, so the hip doesn't catch the waves, possibly giving them cleaner data. And also for a given arm length, the foil is being held deeper rather than out to leeward, which gives them less leverage, and any cleaner data from not having the hip clip waves is then lost by the windward foil constantly trailing in the water. The whole thing is very odd, and I'm a bit of lost to explain it, so welcome to hear your opinions. Possibly it's just that the team hasn't got used to flying the platform high with its unique shaped arms. It could be that the designers just really missed that extending the hip away from the water on the leeward side would also then put the windward foil in contact with the sea on the windward side, but surely they wouldn't make such a schoolboy mistake like that. So is there another explanation? I remember in the old rules there was a section which set out how the windward foil could not impart any hydrodynamic forces, and it had to be raised outside of manoeuvres, and the angle that it had to be raised to was also set in the rule, so this limited what you could do with the foil out of the water. Now, when researching this, I looked at the new rules, and the only mention of a fully raised position for the foils now is that the FCS provides information on when a foil is in its fully raised position. So that raises some interesting questions. What if Ineos's windward foil clipping the water is intentional, so not a side effect of scaling? Could, at extreme flap angles, the windward foil touching the water have some useful input in terms of maybe adding leverage or even reducing leeway? On the 1st of March, the foil cant system specification will be posted, and it may be that this is possible from a rules legality perspective, but is outside the technical capability of the One Design foil cant system, and we'll know more when the rule comes out. So in conclusion, Luna Rossa have created the best scale they can, probably because they want to test as like for like as they can new equipment. Emirates Team New Zealand have made a platform which isn't always the perfect scaling, but creates a boat which in its own right sails well. Ineos, maybe they've done something to get cleaner data, but I'm not sure it's working, or there could be something more suspicious going on. Jury's out there, and I'd appreciate your opinions. Now, if you've enjoyed this video, by all means like and subscribe, but I really don't care. What I would like is for you to join the conversation, so if you've got ideas, post in the comments, I always read them, and if there's someone else you know who would be interested in this, then please share it and get them involved in the debate as well. Yeah, until next time, see you around.